All right, so this is on page 11 of your packet in sample number 3, and it's finding the list of all possible rational zeros of the function using the rational zero theorem. And what the rational zero theorem says is that all the possible real zeros of this function can be found by setting up a fraction of the factors of the last coefficient divided by the factors of the lead coefficient. This will give you all of the possibilities for the zeros that you could have. What it does is it helps us narrow down a list of choices for us to start testing them with synthetic division to see which ones are real zeros, and then go to factor from there. So on your worksheet also, you don't have to find all the zeros in the last one if you could just list the possible zeros. So do the same thing that I'm going to do here, because we're going to be finding all the real zeros when I get back on Thursday. So right here, set up. So first thing is factors of the last of the constant, which is 24, over the factors of the lead coefficient, which is 3. And set up a fraction here. So factors of 24, there's a lot of them. And you always want the positive and the negative factor because it could be a positive or a negative. So plus and minus 1, because it divides by 1, 24 divides by 2, it divides by 3, it divides by 4, 24 divides by, doesn't divide by 6 evenly, or sorry, 5, does divide by 6 evenly. Then it divides by 8 is the next one that it divides evenly by, and it divides evenly by 12, and then 24. So factors of it are numbers that it divides evenly by. So then on the bottom, factors of 3, we only have 2, plus and minus 1. I guess it's really 4 if you think of plus and minus as different ones. And then plus and minus 3. Those are the factors of 3. So then you have to take this list and you have to set up them as a true fraction. So like 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 8 over 1, 12 over 1, 24 over 1. The 1 on the bottom does nothing to it. So first thing I'm going to do is list the entire top. And this is taking care of that 1 as the denominator because it doesn't affect the numerator. So plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 8, plus and minus 12, plus and minus 24. So that's all the numerator, and that's because divided by 1, it does nothing to it, so that's the first set of choices. Now I'm going to think about each of these values divided by 3. If it reduces to be a number that's already in this list, we do not list it. So I'm going to do those in green so you can tell the difference here. So the first one, 1 divided by 3, is not listed. So we want a plus and minus 1/3. 2 divided by 3 is not already listed, so plus and minus 2/3. 3 divided by 3 is 1, and that's already listed, so we don't bother with it. 4 divided by 3 is not here, so we do need to put it. I'm going to continue here below. 6 divided by 3 is 2. That's already listed, so we don't put it. 8 divided by 3 is not listed, so we do need to put it. 12 divided by 3 is 4. It's already in the list, so it's already there. 24 divided by 3 is already in the list, so again, we don't need to put that one. So the solution to this, the list of all possible rational zeros, is all of these. So possible zeros for these equations.